Hello engineers and future marine professionals, welcome back to TechTide Digital Lifestyle, your trusted channel for marine electrical systems, industrial engineering tutorials, and exam-oriented technical knowledge. In this brand new masterclass series we are starting a complete professional course on alternators specially prepared for marine engineers, electrical technical officers, industrial electricians, and fresh engineering graduates. Throughout this playlist we will move step by step from basic principles to advanced shipboard operation, including excitation systems, paralleling generators, protection relays, and troubleshooting techniques used in real engine rooms. If you are preparing for onboard duties, certificate of competency exams, or technical interviews, this series will be extremely valuable. Before we start, please like this video, subscribe to TechTide Digital Lifestyle, press the bell icon, and comment below from which country and rank you are watching. Course Overview. This video launches our complete 10-part alternator tutorial series on TechTide Digital Lifestyle, where we aim to build your understanding from foundation level up to advanced marine practice. Over the coming lectures we will study the construction of alternators, the electromagnetic working principle, excitation and AVR systems, voltage regulation, efficiency and losses, synchronization and load sharing, protection schemes, maintenance routines, and common failure scenarios faced on board ships. For examination candidates we will also solve numerical problems, discuss drawing diagrams, and review typical Viva questions. By the end of this series you should be confident reading generator manuals, operating power management systems, and answering technical questions from surveyors or examiners with clarity and accuracy. Who this course is for? This course has been structured for several groups working in or preparing for the electrical power industry. Marine engineers and ETOs onboard vessels will benefit from the strong practical focus on generator sets, switchboards, and PMS operation. Industrial electrical engineers running diesel generator plants or standby systems will also find the concepts directly applicable. Engineering students and fresh graduates can use this series to strengthen fundamentals before interviews and competitive exams. Even junior officers or cadets entering engine rooms for the first time can treat these lectures as a visual handbook to understand how alternators fit into the ship's electrical distribution system and daily operational routines. What is an alternator? An alternator is an electrical machine that converts mechanical energy from a prime mover, such as a diesel engine, gas turbine, or steam turbine, into electrical energy in the form of three-phase alternating current. This conversion occurs because a rotating magnetic field produced by the rotor cuts the stationary stator conductors, inducing an electromotive force according to Faraday's law of electromagnetic induction. In marine practice the prime mover is usually a medium-speed diesel engine, while in power stations it may be a turbine. Understanding this basic energy conversion process is extremely important, because every control system, protection relay, and maintenance activity is built upon this fundamental operating principle. Why AC generation is used? Alternating current is preferred for large-scale power generation because its voltage level can be easily changed using transformers, which is not practical with DC. High voltage transmission reduces current and therefore minimizes copper losses in cables, which is essential for long shipboard runs and shoreside grids. AC also allows the use of simple and rugged induction motors that drive pumps, fans, compressors, and winches throughout a vessel. In addition, three-phase AC systems provide smooth power delivery and better efficiency for heavy rotating machinery. For these reasons almost all modern marine and industrial power systems rely on alternators producing three-phase alternating current. Alternator vs DC generator. Historically DC generators were used in older installations, but they relied on commutators and carbon brushes which caused sparking, heavy wear, and frequent maintenance. Modern alternators replace the commutator with slip rings or brushless excitation systems, resulting in higher reliability and safer operation in marine environments where moisture and vibration are common. Alternators are also better suited for high power ratings and continuous duty operation. From an examination perspective, you should always remember the key differences in construction, maintenance requirements, and application areas between DC generators and alternators, because this comparison is a very common Viva and written exam topic. Applications of alternators. Alternators are used wherever stable AC electrical power is required. Onboard ships they form the heart of main and emergency generator sets supplying propulsion auxiliaries, navigation systems, lighting, cargo equipment, and hotel loads. In shore installations, alternators operate in thermal power stations, hydroelectric plants, and wind turbines. They are also fitted to standby generator plants for hospitals, data centers, and offshore platforms. Understanding these applications helps engineers appreciate why reliability and protection systems are so critical, especially in marine environments where blackout conditions can endanger safety of life, navigation, and cargo operations. Typical marine generator arrangement. This schematic illustrates a standard marine generator configuration where a diesel engine is mechanically coupled to an alternator through a flexible coupling that absorbs vibration and misalignment. The electrical output from the alternator terminals is routed to the main switchboard, which distributes power throughout the vessel. An automatic voltage regulator continuously monitors terminal voltage and adjusts the rotor field current to maintain stable output during sudden load changes such as starting large motors or bow thrusters. In modern ships, this entire arrangement is integrated into the power management system, which handles starting, stopping, and load sharing between multiple generator sets. Nameplate data and ratings. Every alternator is fitted with a manufacturer's rating plate containing crucial technical information that engineers must interpret correctly. This includes apparent power in kilovolt ampere, rated line voltage, operating frequency, synchronous speed in revolutions, rated power factor, insulation class which indicates thermal limits, and IP protection class describing enclosure sealing. During exams, you are often asked to explain these terms, and on board you must verify them before paralleling machines or connecting heavy consumers. Incorrect interpretation of nameplate data can result in overloads, overheating, or insulation failure, leading to serious equipment damage. Safety. While working, safety must always be the top priority when working on alternators because they involve both high-voltage electrical systems and high-speed rotating machinery. Engineers must strictly follow lockout and tag-out procedures, isolate and earth circuits before maintenance, and wear appropriate personal protective equipment such as insulated gloves and face shields. Insulation resistance tests should be carried out before re-energizing machines after shutdown or maintenance. Never touch terminals that may be live, and always treat generator equipment with caution, particularly in damp marine environments where the risk of electric shock is higher. What comes next? In the next lecture on TechTide Digital Lifestyle, we will examine the construction of an alternator in much greater depth, including stator core and winding arrangements, rotor designs such as salient and cylindrical pole types, cooling systems, insulation materials, bearing assemblies, and terminal box layouts. This knowledge is essential for troubleshooting faults such as overheating, abnormal vibration, or voltage instability. It also forms the foundation for understanding protection systems and maintenance schedules required by classification societies. Make sure to watch the next video because construction-related questions frequently appear in oral examinations and technical interviews. If you found this lecture useful, please like the video, subscribe to TechTide Digital Lifestyle, and turn on notifications so you don't miss the next part of this Alternator Masterclass. Also comment below whether you are a marine engineer, ETO candidate, student, or industrial professional and which country you are watching from, because your feedback helps us improve future tutorials. This is TechTide Digital Lifestyle signing off, and I'll see you in the next video on alternator construction.